Welcome back to the Mr. Gordon Computer Science channel. If you haven't already done so, please hit the subscribe button to get the latest updates, and don't forget to give me a thumbs up for the video. So let's have a look at the exam question topic. In this case, it's stack operations. We can simulate the use of stacks in Python by using certain commands. So the push command, which would add an item to the top of a stack, we are going to use the list method called append. So here we can see we have a list of apple, banana, cherry, and we are appending orange. So we have our three original data items, and we see orange has been appended to the end. So orange is the top of the stack. The list method pop is the same as we'd expect in stack operations. So we have three elements here: apple, banana, cherry. If we pop, that will remove the top element of the stack. So in this case, you can see that the cherry has been removed from the stack. So let's have a look at the detail of the exam question. Input prompt will be asking the user to enter push, pop, or -1 to terminate the program. We're going to allow fruits to be added to the list in a stack fashion. So new items, remember, always are inserted at the top of the stack. A pop operation will remove the stack item and print the data item itself. A push operation will add a new fruit to the top of the stack. The stack limit is defined as having a maximum of 10 fruits. Build-in robustness checks to ensure that data is not removed from an empty stack or added to a full stack. These robustness checks must be in the form of Boolean functions. In other words, functions that return a Boolean value. Enter 1 to exit the program. So now let's look at the pseudocode solution for this exam question. We have our two robustness functions at the top of our program already defined. That allows us to call them in the main body of the program. So let's just look at each function in turn. We have the function isEmpty. We are passing it the parameter representing the stack. So I've used the prefix of p to remind me this is a parameter I'm dealing with. So if the length of the stack is equal to 0, then the stack is empty. Return true, otherwise return false. Let's have a look at the isFull function. Again, we pass it the parameter for the stack. If the stack size is 10, then we return true, otherwise return false. So let's look at the main body of the program now. We declare an empty array called fruits. We get our user input, push, pop, or -1. Now we have our controlling condition for our while loop. So while the value is not equal to -1, so in other words, we are not wishing to terminate the program. If we entered pop and the stack is not empty, that's what that equates to. In other words, there is data in the stack. So if this whole if statement evaluates to true, then it will pop the item from the stack and print it out. If this if statement evaluates to false, we will have a further test asking if we are pushing and that the stack is not full. We shouldn't be able to add data to a full stack. In this case, the stack has already got 10 elements within it. If this line equates to true, then we will enter the fruit name and we will push that onto the top of the stack. We then ask for the next input, push, pop, or -1 to stop. So that is the pseudocode solution for our exam question. For illustration purposes, we will now look at what this code would look like in Python. So now we have the Python implementation of our exam question. So let's quickly run through the code changes. Our function has changed to def. We have our colons where appropriate. Same with our isFull function. So further changes include the if statement. Again, our colons have been inserted appropriately. The else if has been changed to elifs, and notice that the end ifs and the end whiles have also been removed. So let's see what this program looks like when we run it. So here we have the program now running, and it's asking us to pop, push, or -1. So let's push some data onto the stack. So we push, and let's say we push apple, and let's say we push and we push an orange, and let's say we now perform a pop operation. It's now printed out orange as expected, and if we perform another push and we push a plum, and then if we pop, we should see plum. If we pop again, we should see apple, and if we pop again, we should not see an output. And if we now enter -1, it should terminate. Hope you enjoyed the video. Don't forget to give me a thumbs up and subscribe to the channel.